So this is a question from the chapter friction from the IIT JEE previous year question. The question is, a block of mass m is on an inclined plane of angle theta. The coefficient of friction between the block and the plane is mu. Okay, so here this is an inclined plane and the angle is theta, and this is a block of mass m, let us suppose, and the coefficient of friction between this block and the inclined plane is mu, such that this tangent theta is greater than mu. So what does it mean? That like this is the inclined plane and this is our block of mass m here. This is angle theta. If tangent theta is greater than mu, that means this block is having the tendency to move in the downward direction along the plane. That means friction will not be sufficient to hold it with the plane, right? Now the block is held stationary by applying a force P parallel to the plane. Okay, so this is the force P here, which is applied parallel to the plane to keep it stationary on this inclined plane. The direction of force pointing up the plane is taken to be positive. Okay, as P is varied from P1. Okay, so this P1 is given as mg into sine theta minus mu cos theta, right? And this P2 is given as mg into sine theta plus mu cos theta. So the value of P is varying between these two forces. Okay, now we have to draw the graph between the frictional force F versus P, that is the applied force. Okay, so first of all let us draw the FBD diagram of this block of mass small m. So let us draw here. This is our block of mass m. What are the forces acting on it? So one force will be in downward direction, that is mg, due to the gravitational attraction of the earth. One force will be acting like this, that will be normal force, right? And this angle, as we know that this angle will be theta. Okay, so there will be a component of this mg in this direction, that will be mg cos theta, and there will be a component of this force mg along the plane in downward direction, that will be mg sin theta. Okay, one more force is acting, that we have applied in the upward direction, P. Okay, and one more force is there, that is the frictional force. Let us suppose frictional force is equal to F. Okay, so what we are going to do is, initially let us suppose the value of this P is equal to mg into sine theta minus mu cos theta. Okay, and the value of this frictional force will be equal to mu into n, right? And from this free body diagram we can say that this normal force will be equal to mg cos theta. So just by putting this value, we can get the frictional force will be equal to mu mg cos theta. But this is our frictional force. Now we should take care of the thing that what friction actually do. So friction is like the force which always keeps the bodies, which always keeps or try to keep the two bodies together. Okay. So this force P is acting in upward direction, whose value is like this: P is equal to mg into sine theta minus mu cos theta, and this mg sine theta is acting downward. So which force is greater than here? Obviously this force mg sine theta is greater. So friction will be acting in a direction such that it will always try to keep this small m with this inclined plane together. So the friction will be acting in upward direction in this case. So this is the direction of frictional force here. Okay. So that the acceleration of this block of mass m will be 0. So in this case we can write the net force in upward direction will be equal to net force in downward direction. That will be equal to mg sine theta will be equal to this force applied P plus this frictional force. So that will be equal to mg sine theta is equal to, what is the value of P? That is mg sine theta minus mu cos theta, okay, plus mu mg cos theta. So this term will be cancelled out. We will be getting here mg sine theta will be equal to mg sine theta. That means there is not any type of force acting on this block of mass m along this inclined plane. So net downward force is equal to net upward force. So this is the downward force, this is the upward force. So block's acceleration will be 0 in this case. Okay. Now let us take the another case here. This is our block of mass m. In a similar way, this is mg acting downward, and this is angle theta, and this is the normal acting. This is mg cos theta, and this is what? Mg sin theta. Okay, and this is a force acting P. Now in this case, let us assume this P is equal to P2. That is what? Let us see. This P2 is mg into sin theta plus mu cos theta. So here P2 is mg into sin theta plus mu cos theta. Okay. So in this block there will be a friction force acting, let us suppose that is F, and we know that the maximum value of this friction force F max will be equal to mu into mg cos theta. Okay, so in this case, when P is equal to mg into sin theta plus mu cos theta, that means this P is greater than mg sin theta. Okay, so in this case friction will change its direction, because what friction do is it always keeps the bodies together. It always try to keep the bodies together. Okay, so friction will change its direction and friction will be acting in downward direction here. So here net downward force is F downward, we will write that will be mg sin theta plus this frictional force, that will be equal to mg sin theta plus mu mg cos theta, right? Okay, now let us suppose this F upward force is equal to P, that is equal to P2, which is given as mg sin theta plus mu cos theta. So what we are getting here, F upward is equal to F downward force. So the acceleration of this block of mass m will be 0. That means your block of mass m is stationary. Okay, so now we have to draw the graph between this frictional force and this applied force, right? So I have directly taken the answer from the given options. So let us draw here. This is our y-axis and this is our x-axis. In this axis, let us suppose frictional force we are taking, and here is the applied force. Okay, so for the lowest value of this for the lowest value of this applied force, P1 is equal to, that is what, mg into sin theta minus mu cos theta. Our frictional force is acting in upward direction, that is positive. So here is frictional force positive, so here F is equal to positive. That will be the maximum value of this F, that is mu mg cos theta. Okay, but when the value of this P is like P2, that is equal to mu mg into sin theta plus mu cos theta, then friction force will be acting in downward direction, that means negative. So we will be joining these two lines, and this point will be equal to minus mu mg cos theta. Here negative sign represents that the frictional force is acting in downward direction. So this is your P1 here, this is your P2. So one more thing I will discuss here, that this point, let us suppose this point is O. Okay, so in this case, at this point O, let us take the situation, this is the block of mass m, and this is the force acting in downward direction mg, this is the normal force, and this is the angle theta, this is mg cos theta and this is mg sin theta. Since our this force applied P is varying from P1 to P2, so let us take an intermediate case when the value of P is equal to mg sin theta. Okay, so this is the P here. When P is equal to mg sin theta, then what will be the frictional force acting on this block here? Since this P is equal to mg sin theta, that is equal to F downward here is equal to mg sin theta on the block, and F upward that is equal to P, that is also equal to mg sin theta. Since net force on this block is 0, then there is not any need of friction, so to keep these bodies together. If friction will act, that means body will start moving, but friction does not want this, that body lose their contact with another body. Okay, so in this case your frictional force will be 0. This is the intermediate case. So this is the intermediate case where frictional force will be 0. Now we can also take that, let us assume your P is somehow between P1 or let us suppose mg sin theta. Okay, and the another case here, P2 from P and between sorry, the another case is this is your P and this is your mg sin theta, between mg sin theta and P2. So in this case your friction force will be acting in upward direction, and in this case your frictional force will be acting in downward direction. That means downward direction and upward direction means upward direction along the plane, okay, it is also along the plane. So from the graph we can clearly say that in this region friction force is acting in upward direction, and in this region friction force is acting in downward direction, that is downward direction. We can also prove it mathematically, but I have taken one intermediate case so that we can understand it. Okay.